Hello and welcome back. Today I've got a fascinating geometry puzzle for you. Here's what we have. We have a right-angled triangle, and inside it we inscribe a circle. Notice, this circle touches the triangle at 3 different points. We are given that one side of the triangle measures 40 units, and the circle has a radius of 4 units. Our goal is to find the height of this perpendicular side of the triangle. So, can you solve this? Oh, don't worry. We'll solve this step by step using a clever combination of geometry principles. Now, to solve this, there are multiple ways to crack this problem, but today we're using one of the most powerful tools in mathematics, the Pythagoras Theorem. But here's the twist. We'll also use some circle properties to make this work. Trust me, it's going to be really interesting. Let's label everything clearly so we don't get confused. This is center of our circle, and we call it point O. Now, we are given name to these 3 vertices of the triangle as A, B, and C. Look, this circle touches the 3 sides of the triangle. The point where it touches the triangle is points D, E, and F. Since we are given the radius as 4 units, so if we draw another radius, OD or OE or OF, all have the same length, that is, 4 units. Because we know the radius of a circle is the fixed constant distance from the center of the circle to any point on its circumference, fixed distance means no matter which point on the edge of the circle you choose, the distance remains same. Here's something cool. Look at the quadrilateral DOEB. Can you see what shape it forms? Yes, you are right. It's a square, because all the angles are 90 degrees, and all sides are equal 4 units. So, point DB is equal to BE, which equal 4. Okay, let's pay attention to this part because it's important. We know this base BC is 40 units, and this BE is 4 units. So, let me ask you, what's EC? Okay, it is quite easy. Simply subtract BE from BC, and we get EC. So, BC is 40 and BE is 4. So EC is 40 minus 4, which is 36. Now comes the game changer, the tangent property. We have a beautiful rule in geometry, that is, when 2 tangents are drawn to a circle from the same external point, they have equal lengths. Now, let me show you something important. Look at point E, where the circle touches the base of the triangle. When a circle is inscribed inside a triangle, meaning it fits perfectly inside and touches all 3 sides, each point where the circle touches a side is called a point of tangency. So the line segment CE is a tangent because it's part of the triangle's side that touches the circle at exactly one point, that is, point E. Similarly, CF is also a tangent because it's part of another side of the triangle that touches the circle at point F. Both of these tangents come from the same external point C, which is a vertex of the triangle. So, we know that CE is 36 units, and we just discussed that when 2 tangents are drawn from the same external point, they have equal lengths. Therefore, CF is also 36 units. We just used the tangent property at point C, right? Well, the same principle works at point A. Look at point A, the top corner of our triangle. The circle touches 2 sides of the triangle, creating 2 tangent segments from point A. AD along one side and AF along the other side. Since both tangents originate from the same point A, they must be equal in length. But wait, we have an issue. We don't have a number for this length yet, unlike at point C, where we calculated 36 units. But don't worry, this is where algebra comes to the rescue. We'll use a variable. Let's call this unknown length x. So we can write AD equal AF, which equal x units. Now we are going to figure out what x actually equals in just a moment. Now, from here, everything starts to come together beautifully. Let's build the three sides of our triangle using what we know. First, the hypotenuse, AC. Look at side AC. Notice that it's made up of two segments, AF and CF, where AF equal x unit, the tangent from A, and CF equal 36 units, the tangent from C we found earlier. By adding these two, we get the total length of AC. So the total length of AC equal AF plus CF, and it equal x plus 36. Next, we are going to find the length of perpendicular AB. Look, side AB is also made of two parts, which is AD and DB, where AD equal x units, the tangent from A, and DB equal 4 units. So the total length of AB equal AD plus DB, that is equal to x plus 4. Finally, the base, BC. It was given to us from the start. Now, take a look at what we have. Hypotenuse equal x plus 36, perpendicular equal x plus 4, and base equal 40. Can you see where we're heading? Yes, we have all three sides of a right triangle. So what do we use for right triangles? The Pythagorean theorem. All right, this is where the magic happens. Our hard work is about to pay off. We're going to express each side of our triangle in terms of x. So it's time for the main event. This is where we bring out the Pythagorean theorem to solve for x. The Pythagorean theorem states, for any right-angled triangle, the square of the hypotenuse equals the sum of the squares of the other two sides. Now let's plug in these values. Hypotenuse equal x plus 36, perpendicular equal x plus 4, and base equal 40. So our equation becomes x plus 36 square equal x plus 4 square plus 40 square. Here, we're using the algebraic identity, that is, a plus b whole square equal a square plus b square plus 2ab. So the left-hand side become x square plus 36 square plus 2 times 36 times x. By simplification, it becomes x square plus 196 plus 72x, while the right-hand side becomes x square plus 4 square plus 2 times 4 times x plus 40 square, and it equal x square plus 16 plus 8x plus 1600, or x square plus 1616 plus 8x. So our equation becomes x squared plus 1296 plus 72x equal x squared plus 1616 plus 8x. Now let's simplify it. Notice that x squared appears on both sides, so they cancel out each other, and it becomes 1296 plus 72x equal 1616 plus 8x. By rearranging this, it becomes 72x minus 8x equal 1616 minus 1296. Now, after subtraction, it becomes 64x equal 320. Dividing both sides by 64, and we get x equal 5 units. Awesome! We found x. But remember, we needed to find the height AB. Right, which equals x plus 4. So, AB equal 5 plus 4 equal 9 units. And that's our answer. The perpendicular side of the triangle is 9 units. If you enjoyed this problem, click the like button and subscribe for more amazing math content. See you in the next video. Keep learning, keep solving. Good luck.